I specialize in the literature of the Middle Ages. And here you can think of the legends about King Arthur and his knights, or the stories surrounding the Emperor Charlemagne, but also other chivalric or heroic narratives like Beowulf. This literary heritage was an absolute mainstay of the culture in medieval Europe.
However, we know for a fact that many medieval books haven't survived, and so many stories must have been forgotten. There have been dramatic library fires in the past century in which we lost many books. But even without such tragic disasters, people actively disposed of medieval books and recycled them in creative ways. In one famous case, the remains of a chivalric romance were used to strengthen the mitre of a bishop. How can we account for what has been lost beyond retrieval?
This problem is not unique to medieval literature. When studying the history of human culture, every scholar, no matter what their domain is confronted with the same problem, namely that the transmission of artifacts from the past is incomplete.
The sample of historic books, coins, paintings, etc. that survives is but a fraction of what once existed. This phenomenon is known as survivorship bias. This is a problem in medieval studies, but also in fields like archaeology or paleontology. Only a fraction of the original material has survived to our times, and we don't know how large or representative this fraction is.
Because of this, we run the risk of underestimating the diversity of cultural production in earlier societies. Now, we discovered that survivorship bias also plays a major role in ecology, and this field has a rich tradition of statistical methods for bias correction.
We worked with a very famous unseen species model, namely Chow-1, which was developed by Anne Chow, one of the authors on our team.
Biodiversity or ecodiversity, the number of distinct species living in a certain area, is a major research topic in ecology. Ecodiversity, however, is extremely hard to measure.
Whenever you start counting the animal species that live in a certain area, you will always miss species that are hard to observe, like, for example, snow leopards, which are notoriously hard to spot. Now, unseen species models, like Chow-1, can provide a robust statistical estimate of how many species you are likely to have missed when you were out counting in the field.
In our research, we assumed that literary works can be treated as species in ecology, and the manuscript copies of these works can be treated as sightings of a species. And this means that we can apply the exact same formula, Chow-1, to estimate how much medieval literature was lost over time.
In our paper, we estimate that about 9% of the medieval manuscripts containing chivalric or heroic stories have survived. We calculated the survival rates for 6 medieval language areas separately: Dutch, English, French, German, Icelandic, and Irish.
Surprisingly, Icelandic and Irish display relatively lower loss rates. This indicates that these island literatures, although they were smaller, sustained losses that were not as bad as those in the continental literatures of the time, such as French. That is striking.
How is that possible? We discovered that the original evenness of these island literatures was higher. This is again a concept that we borrow from ecology, implying that there is a more even distribution of copies over works.
An ecosystem that is more even will typically also be more stable in the event of external forces, events such as wildfires or, for example, library fires in our case, which can threaten the diversity of a cultural ecosystem, resulting in loss.
The fact that these isolated island cultures behave differently is interesting because in ecology too, islands are a special interest. The endemic species richness, for instance, is higher on islands than on the mainland. So if islands are indeed better able to preserve their biological heritage, could the same be true for their cultural heritage?
Now, simulations in computational anthropology and cultural evolution suggest that the network structure of a society influences the cultural production of that society. Now, more specifically, we found that a society in which there are fewer connections between individuals is characterized by a higher evenness.
Apparently, social networks with fewer connections can indeed realize a more even distribution of the number of instances per cultural artifact, or in our case, the number of manuscript copies per work.
We think that our work opens up a new line of research in the study of human cultures of the past. There is nothing specific to ecology about the Chao 1 method.
In fact, the applicability of this method is far wider than our case study in medieval literature would suggest. And this calls for a broader application of this method across the heritage sciences, such as through ancient coins, fairy tales, or even forgotten painters. The possibilities are really endless.